Welcome back, guys. So we have seen different applications of MATLAB in plotting and numeric calculation as well. We have also seen the application MATLAB while we have to solve different number of equations. So we have seen a method which was basically on the basis of the finding the inverse of a fat matrix and multiplying it with the vector will give us the output vector matrix. Okay, so today we are going to find a method which is based on the equations, and we are going to find the solution of different equations as well. Okay, so let me go to this page and let me have some equations. So suppose the first equation we have is 4x square plus 2x plus 1, and we have to find the solution of it, and the solution of it will be the roots of this equation. Okay, so finding roots of this equation, basically there are two roots of this equation. Why do we have two roots? Because the order of this equation is 2, so therefore we have two roots, and in order to find the roots of it in MATLAB, what we have to do, first of all we have to write the coefficients of this vector in the MATLAB format, and writing it like here we have 4, 2 and 1. These are the elements here, and after it we have to apply some functionality. Okay, similarly if we have other type of equations as well, let me have 5x4. okay, so in order to convert it into the MATLAB vector, what we have to do, we have to write here 1 0 0. This is the fourth coefficient, this is the third, this is second, this is the first, and this is the DC term. Okay, so these are basically the coefficients in it. We have 4 zeros while one coefficient with which the equation will be here. So here with x of 4 we have 5. So despite writing 1 here, what we can write here, we can write here 5. Okay, so after it we have to apply some function over it. Okay, so what are those functions? Let me go to the MATLAB command window and writing here my first function as a equal to, what was that? That was basically the 4 to 1, and this 4 to 1 is basically this equation 4x square plus 2x plus 1. Okay, so that is 4 comma 2 comma 1. Okay, so this is my vector here, and in order to find the solution of it, we have the function here, and that is the roots. Okay, so writing it here, it will give me the roots, and we can very easily see that in this equation the roots are basically complex. Okay, similarly if we have another equation, and that is x square plus 2x plus 1, that is a very well known equation. So let me write it here again. So another equation here is x square plus 2x plus 1 equal to 0. Let me write it here, and we can very easily see that the root of it will be minus 1 because two roots here, and these two roots will be here because this is now x plus 1 whole square equal to 0. Okay, so let me write the coefficients of it, and let me write those as c equal to 1 2 1. Okay, and then finding the roots of it, how would we find it? Let me go here again here. So it will be 1 2 1. Okay, and writing roots here as well, it will give me minus 1 minus 1. Okay, so that is it. Similarly, in order to find the roots of my equation b, which is here, okay, this was basically the equation b, and here we have to find the roots of this equation. How would we find it? So writing it now 5 0 0 0 0. Okay, so how many roots will I have? I will have 4 roots. Okay, so writing roots and b with it, I will see that the roots here are zeros, and it is also clear from this equation as well that the number of roots here are 4, and all of these are basically 0 because only the value of x equal to 0 will give me this equation equal to 0. Okay, so that is about the root equation, and we have seen the applications of it in finding the solution of the number. Okay, so with the next lecture we will try to use some more methods in solving different equations as well. Till then, take care of yourself.